world needs more reliable, carbon-free energy to power a cleaner tomorrow. But new technologies are needed to supply this energy. Terrapower and GE Hitachi Nuclear Energy brought together their decades of design expertise and technical capabilities to develop the NATRIUM technology. This innovative clean energy source combines an advanced reactor with a molten salt system for energy storage at the gigawatt-hour scale. The NATRIUM technology is tailored to support electricity grids with a growing mix of renewables. The NATRIUM reactor creates heat, which is used to increase the temperature of molten salt. That salt is then deposited in a hot salt storage tank. Operators independent from the reactor can use the heat to generate electricity immediately or reserve that energy for later. The stored heat allows the NATRIUM system to be uniquely flexible. It can rapidly ramp electricity production up or down based on demand or the availability of renewable sources. The NATRIUM technology will be available as early as the late 2020s, making it one of the first commercial advanced nuclear technologies. Learn more at natriumpower.com.
Okay, hello everyone. My name is Brian Sardo. I'm joined here with Adam Sneath, and we are here to present on the NATRIUM Nuclear Demonstration Plant fuel handling simulation and how we implemented this in SIMIO. Specifically, we'll be talking about the practical applications with the use of this model. One thing that has been very helpful for us has been a set of hypercare hours that is offered by SIMIO, and Adam has assisted us in making this simulation a reality. What do we need SIMIO for the NATRIUM demonstration plant? Well, as you saw, this is a nuclear demonstration plant, so we need to move fuel around. And when you're moving fuel around and into the reactor and from the reactor out into this area called the fuel handling building, the reactor needs to be powered down during that time. So ultimately that's called a refueling. And in that refueling period, like I said, you cannot be supplying power to the grid because the reactor has to be shut down. So we want to minimize the duration of that shutdown time frame. The refueling needs to be as minimal as possible so that the power can be supplied to the grid. So in order to understand exactly how long a refueling is going to take without a reactor built and a demonstration plant built, we wanted to simulate using SIMIO the fuel assemblies moving between the reactor building and the fuel handling building. So as you can see in this overview, we have the fuel handling building, we have the reactor, and then we have the reactor building. The reactor itself is below grade for safety purposes. The fuel moves into the reactor, or rather the fuel handling building upon receipt. It then goes into a series of chambers to be conditioned and ready to be implemented into the reactor. And then this tool, which we'll talk about a little bit more later, the X-Vessel Handling Machine, EVHM, moves those fuel assemblies over from the fuel handling building to the reactor building so that you can exchange fuel at the reactor. And then once again, as the reactor emits or discharges fuel assemblies, the EVHM, which is on rails, can move it from the reactor area back onto the fuel handling building for processing. So it's an exchange of fresh fuel assemblies and discharged fuel assemblies, ones that have lived their life and provided as much power as they're going to the grid.
Hey, Brian, can I jump in with one additional point? Thanks. Hey, everyone, Adam Sneath here from SIMIO Solutions Engineer. I've been working with Brian on this project. I think it's been a great application of simulation because it's allowed Brian to create different scenarios, right? And create scenarios around the different parameters in the system, the processing times and so forth, to see how that overall time span has been affected. So I think that's really been a an effective use of simulation to address the business problem. Just my 2 cents there. Back to you, Brian.
All right, great. So one of the things that was particularly important for this model was the use of graphical representation for the fuel handling building and the reactor building and the various components moving those fuel assemblies back and forth. We even were able to implement fuel assemblies to scale in the simulation itself. So in taking these two buildings, they needed to be to scale. So in order for us to do that, we were able to bring in various models from this program, Aviva, or if you have SolidWorks programs, or rather parts, you can bring those in and ensure they are to scale. And we like to use the layer feature in order to turn these on and off, because it's very important to us that the scale for the reactor building and the fuel handling building is correct. However, while the simulation is running, they really don't need to be turned on, so to speak. We're mostly using these buildings as a sense of scale to understand how far fuel assemblies have to move between the two buildings, and also what those speeds are that are associated with the components moving the fuel assemblies back and forth. So I'll just show real quick what it looks like in the model, how easy it is to use these layer features and then deactivate and activate them as well. Oops, got the wrong window open here. Let me just minimize this. So as you can see up here, we have symbols, but ultimately you want to be on the ribbon for visibility. And when you bring a specific component in as an object, or rather as a symbol, you can turn the visibility on and off. So as you can see here, I have a layer called Fuel Handling Building, FHB, and I also have the reactor building layer. And then we went a little bit further and added some. So with our SIMIO drawing layer, we basically have all of our SIMIO objects built onto this layer. So you can quickly turn those on and off too if you just want to see what one particular item looks like the fuel handling building in this case. So like I said, when you have these buildings on and you're looking at a 2D rendering of your simulation, if I hit run, you wouldn't see very much because everything's happening on the inside of the building. So while we're doing the run and making our recordings, we turn these layers off so that you can clearly see what's going on as the refueling unfolds. One thing I didn't note so far is how easy it is to change a layer. So you can pretty quickly right click and hit set layer and change whatever it is that you'd want. So if I change this to fuel handling building, it would disappear because we don't have it visible at the moment. So that is also something you want to be aware of while you're using layers. You want to be mindful of which layer you are on as you are creating items, because if, say, you are on the fuel handling building layer and you bring a server in, well, the server is not there. That's because it was built back in the fuel handling building layer. So if you did goof up, and that might have happened, like I said, you can right click in here and turn it on to one that was visible at the time. So now we have server one still being visible because I changed this layer to SIMIO drawing, which going back to the layers is shown here as visible. I believe that's all I have on layers at the moment. Adam, do you have anything you wanted to add to that?
Sure, just one final point there is that this feature was put into SIMIO about a year ago. Exactly, I just pulled up the release notes to remind myself. So if you're seeing this and you don't have this feature, if you're not sure if you have this feature, you can always check the release notes from the support ribbon, which outline all new developments. So we release a sprint version of SIMIO every 3 weeks, which are really diligent users may choose to stay up to date with. We have a major release about every 6 months. But features like this in particular, may be a good reason to stay up to date with your version of SIMIO. And if you ever had questions about how to update Simio, you could reach out to support@simio.com for a little bit of help. But yeah, looks great, Brian. Thanks for sharing that feature.
Anytime. So going back to the slideshow, like I said, it's easy to activate and deactivate the features. Let me just make sure I haven't missed anything here. Nope, looks like we have everything we wanted to say about that. I kind of just went over this while we were in the model. It's very, very important to make sure you know what layer you're on, and you can always right click and edit the layer after the fact if you maybe built it in the wrong layer. The next feature that I like to talk about is use of 3D models for a realistic view. With the first few models that we built, we didn't have a realistic view to our simulation, but it quickly became apparent that it took longer to explain what it was that it was going through the fuel handling building and out of the reactor and in and out of the reactor. So it was important for us to take and understand how we could give it a realistic view. And while that may sound like something that isn't necessary to have a good simulation or a very accurate simulation, that might be true, that it doesn't change the accuracy of the simulation. But for those that are reviewing and have no idea what Simio is, or just need to know what is going on in the simulation. For instance, we have investors that are investing in our company, and they need to know what is going on in the simulation. So in order to do that, we wanted to create a realistic view. And ultimately, we were able to do that by conveying the simulation process. If you're not sure and you don't have 3D models, I recommend you go to a link such as the one that I posted here in the presentation. There are a number of other 3D model generators which you can get free 3D models and implement them into your directly into your simulation. And you can use the import symbol feature in Simio to import all sorts of file types like step files, DWG files, Blender files. There are many. OBJ file is another one that we used quite often. So the file itself will appear in the symbol folder on the right, and you can do further color and scale refinement. And I'll come to that bullet point after I show a little bit in the model here. So like I said, underneath the drawing ribbon, you can go here and place symbol, and you can see all the various symbols that we used throughout that we have pulled in. The ones that you pull in typically will show up at the very top, and you can use the import symbol feature to go ahead and grab your file. Sometimes you won't see that file, so you may want to go back to the original spot where the file was generated and make sure that it is in a compatible file format like the ones that I mentioned in the presentation slide. So when you do pull them in, they do show up on the right-hand side of the symbols. And you can see we went pretty crazy with our symbols. Probably didn't use half of them. I mean, we certainly didn't use the Tesla Cybertruck, but you can see that that is in an STL format. We were just playing around a little bit and found a Tesla truck that you can bring into a Simio model. When you do have that symbol pulled in, you can go into the symbol, edit the scale as necessary. And then when you bring it into the model, one of the convenient things is if you were mindful about the scale as you were building the model, you can pretty quickly understand if your item is to scale or not. So you can see using the scale on the upper portion or of the grid here, you can see roughly what the scale is, and also back in the symbol area, you can understand what the size of your truck is, or your task transporter in this case. One of the things that we did to begin with was we had an AutoCAD file that was showing a plan view of the fuel handling building and of the reactor building. And we brought that in because it was a very detailed plan view. It's not shown here in the model because it just very much clutters your model, but you can bring it onto a layer that you can turn off later. So for us, we called it FHB AutoCAD file, and we did the same thing for the reactor building as well. And then you can line up that plan view pretty accurately with the scale on the model, on the facility outline. And ultimately what will happen is it gives you a point of reference for the entire time that you're drawing your SIMIO objects or bringing in symbols. So that was one of the things that I think really helped us out with the scale of the model. You can see some of the remnants of it over here on the left-hand side. We don't use this very much in the simulation, but if you are going to do that, occasionally you will have issues with clicking onto various objects. So you may want to clear that out once you are comfortable with the scale of the AutoCAD file or whatever file it is that you're using to confirm scale of your model. Let me see if I have anything more left on that slide here. Yeah, one of the nice things is occasionally your symbols will come in and they will be in grayscale. I think that there has been an update to that in SIMIO and they will come in, but if you use something like an STL or a step file, occasionally it'll come over and it won't have any color. So you can either re-implement the import with using a different file, or if you're comfortable with, say, this truck, with just some coloring so that it's not all grayscale, you can pretty easily edit the color in the symbol feature in SIMIO. I think that is all I have on this slide. Adam, did you have anything as I was going through?
No, it's great. I'm glad you touched on the scale. Well, I guess I should have said yes. Just a quick point or two. I also use 3D Warehouse quite often to get free 3D symbols that you can import nicely to Simio. So that's just 3D Warehouse. You can Google it. And I think this model is a great example of just enough animation to get the job done. And Brian really nicely explained, why that's important for stakeholders and consumers of the model. As the technicians and the analysts, we're focused on the results and the number crunching, but adding some of this, realistic view can really help people who are not familiar with the simulation understand and intuit what's happening with the model and ultimately have more faith in the results of the model. Very good. Back to you.
Great. Thanks, Al. Okay, on to the next slide. I think this is the last major topic that we have to talk about in the practical applications in the Natrium refueling model. But this one was pretty important in that we wanted to, when a fresh core component goes from the fuel handling building onto the reactor and then is discharged as a discharged core component, so it's not truthfully the same entity. It is in SIMIO terms the same entity, but in terms of the simulation, it's actually a fresh core component going into the reactor and a totally different core component or fuel assembly coming out of the reactor. But to simplify the model and to simplify the simulation, it's effectively the same entity that changes color from blue onto red as it comes out as a discharge core component. And our X-vessel handling machine needed to be seized at the reactor while that exchange was taking place. So we found that the use of a worker, in this case, instead of a vehicle, achieved that goal because the X-vessel handling machine being seized at the reactor, the technical details are that the X-vessel handling machine will be prioritizing a seize request over all else. So in order to orient the worker as well, it was easier it was rather the X-vessel handling machine. It was easier to orient the worker rather than the vehicle in this case. So we used, like I said, a worker instead of a vehicle. This is kind of unrelated to the title of the slide, but we use data table links at the server, the reactor, to dictate a dynamic time scale for a fresh core component to discharge core component exchange, because it wasn't necessarily the same amount of time it would take to go from a fresh core component to a discharge core component. So the use of data tables was pretty important in that you could dynamically change the amount of time contingent upon, well, if this was fresh core component number 1 coming over, or was it fresh core component number 7 coming over. Say fresh core component number 1 takes 30 minutes and fresh core component number 7 takes 45 minutes to exchange. Well, we were able to use those data table links to dynamically change that time depending on what sequence of events we were at. And one last tidbit is just that we're able to, once again, just change the color. So it was really nice, yet another really nice graphical representation. Okay, I'm discharging this core component, which is red, because radioactively it's very hot at that time. So red is a very easy way to represent, okay, we're not going to be near this at that time. It's coming out of the reactor, where this fresh core component coming over wouldn't necessarily be radioactive or as radioactive. So it was a nice way for a nice visual for everybody to see, okay, this has gone from fresh to discharged. And Adam, I think there was something you'd like to show off in the model a little bit at this stage, if I'm not mistaken.
Perfect. Yeah, if we can flip back to the model. And so let's select, and I think we layered it elsewhere. You may remember where it has gone to with our layers. Sweet.
Yes.
Okay.
Go ahead and
Great.
set the layer a little bit differently, so we can look at it a little bit more easily. There we go.
Beautiful. So you all can see when Brian selects the EVHM on the right-hand side by our properties window, this is a custom object of type my EVHM. Then Brian, can you click into that custom object's properties, just so we can confirm that it's parent object. So now we can see like the second line there under the advanced options says parent class worker, right? So this started as a worker and we've created a custom object from it. Now, can you pull the help doc up as well? I just want to call that out. And I will, I realized as we were going through, I will ask you to search worker instead of vehicle. There is a very similar help topic for worker discussion examples. If you just do worker, it should be the first thing to pop up. Awesome. So yeah, any of these discussion and examples help topics, just as a side note, related typically to standard library objects. For instance, you have a source discussion and examples help topic as well. I find myself coming back to these because they have a lot of sort of example ways you might use this object or things you might run into. And here we see, for instance, there you have seizing a worker for non-transport tasks. So what's really sort of nice, if you know about it, with the worker and the vehicle really, you can use them for transport tasks and non-transport tasks. The seize or non-transport tasks will always be prioritized first. Now, Brian, can you go back to the model for just one more sec and click the EVHM again? Just one more thing I want to call out. So back in our facility view, great, on the object itself. Yeah, so let's see, in the travel logic and the transport logic. Can you expand the transport logic category on the right? I want to see if we used, no, so maybe can you grab the crane? I know we did it there. Okay. I thought we had, but anyways, you'll all see in that transport logic category at the top, we have a task selection strategy. So that selection strategy pertains only to transport tasks. So another thing we've done in this model, and I think it's in a newer version, is we've created priorities for the different moves, right? So if there are two competing crane moves, we assign model entity priority higher or lower so the crane knows which one to select from its queue of transport requests. However, any seize requests on that worker or vehicle would come before any of those transport tasks. So just wanted to explain that a bit and also point out the help doc so you can reference it. But it's, it's really important to think about how those, requests sort of rank against each other so that we can control it the way we need to. And that's all I got.
Great, thank you, Adam. Okay, that concludes our presentation. If there are, I recognize this is not a live presentation, so if there are any questions about the features that we discussed here in this presentation, I'll make sure that my email is posted to the SIMIO Sync website, and you can also find additional public resources on the NATRIUM Demonstration Reactor. One particular one that we're very excited about, I believe, is this second from the bottom link here, about building in Wyoming in the late 2020s. And the use of this simulation has allowed us to go into that build confidently and understand how long our refueling will take. So that is a critical parameter, once again, for any investors. They would like to know how long will it take. And it's also a critical item in terms of how long we'll be able to provide power to the grid in any given year. So this simulation has helped us in achieving that goal. And I want to thank the SIMIO team, especially Adam, for helping us out with that simulation and ultimately helping us achieve the goals of building something that we think will benefit the greater public.
Yeah, thank you, Brian, for a great presentation. I think it's a cool topic, and nuclear is a little bit of a passion of mine, so it's been really fun to work together. And for the folks listening, you may have heard Brian mention, the hypercare remote support, as it's called. If you're interested in having a little extra muscle on your modeling projects, reach out to your SIMIO account manager. Hypercare is basically consulting or a service that we sell as a project. So it's at cost, project specific support. So it's sold as 10 hours, 20 hours, or a bundle of hours. But personally, I love working with you. It's a great way for me to learn about different industries and different technologies. So reach out if you're interested in that. But thank you so much, Brian. Really great presentation.
All right, well, thanks for your help, Adam. And like I said, if anybody has questions, feel free to reach out. Thank you very much.
Due to the time constraints today, we do have a question, only one question for you. Can you elaborate on the importance of these simulation results? How costly are unexpected delays during the refueling cycle?
Sure thing. Eric, can you hear me?
I can hear you.
Okay, great. So it really depends on the reactor and how much power is produced out of that reactor. But the value that has been thrown my way in the past has been a refueling costs $1 million per day. So dividing that by 24 hours is quite a lot of money, even if you only have a 1 hour delay. So as a result, any delay to our refueling goals results in money lost, and also less power being powered to the grid in any given year. So that's why such an emphasis is placed on how long a refueling is and how long a reactor is down. I live maybe 2 towns over from the Millstone reactor plant, which is one here in Connecticut that produces 2 gigawatts of energy. And we have friends that work there, and they're on call for 24 hours a day, sometimes sleeping at the plant during those refueling periods. So it's a really important time to get right. And that's where this simulation certainly has been helpful for us.
All right. Well, thank you, Brian, so much for your presentation today. And thank you so much for participating in Simio Sync. It was an awesome presentation. And thank you, Adam, as always, for helping with this presentation as well. And look forward for you guys presenting it, hopefully, the next Simio Sync. Have a great rest of your day.